Hello, and welcome back to another analyzation of a free response question. I'm back at it here with the non-calculator question that we did in class. So it was the one with the graph. It's question 22, or from the year 2022, question 3. So, I'm just looking at the scoring guidelines and we're just going to discuss why the solution is what it is. So, they initially ask us to find f of 0 and f of 5. They gave us f prime. So, if this were f, this would be the easiest question ever. You would just look at this point and go, oh, that's at 0, so f of 0 is 0, and f of 5 appears to be at 1, right? But that's not what we're doing, right? I wish it was, but it's not. So, how do we use the graph of f prime in order to solve for the values of f? Well, we all know that the integral of f prime is f, okay? The integral of f prime is f. That's pretty useful. We're trying to find f. We're trying to solve for f at 0, and we're trying to solve for f at 5. So how do we solve for those specific values? Well, if we integrate, when you integrate f prime along a certain set of bounds, what are you finding? You are finding this would be equal to, oops, my fingers are on the wrong spot. This is equal to the change in f along the interval. So, in other words, the integral from a to b of f prime is the distance f moved up, down, left, right, however you want to think of it, over the interval a to b. Okay? Okay, that is extremely important. The integral of a derivative will result in a position, basically put, right, in a value. The integral of a derivative will result in a value. If the original function f gives you values, the derivative gives you slopes. Well, the integral of the slopes will give you the value that you're looking for. Okay? So they told us this fact that f of 4 equals 3. So that means at this particular time, at t equals 4, f equals 3. So if we take the integral from 4 to 5 of f prime, that's going to tell us how much it moved. Well, the integral from 4 to 5 is simply a half, because the area of that triangle is 1/2. Because remember, integral is simply area under the curve. So the integral of f prime from 4 to 5 equals a half. Does that mean f of 5 equals a half? No, that's how much it moved, but you can't forget that the starting position was at 3. So if we add the 1/2, that will give us the end position, 7/2 or 3.5. So when you integrate a derivative, it tells you how much a particle moved. Not where it is per se, but how much it moved. So if you already know that it was at 3, when you take this integral, it's telling you, hey, it moved up a half. So now we're at 3.5. Okay? And so similarly, the same is true if we do the integral from 4 to 0 of f prime. Because now we're trying to backtrack, right? To go back to 0. And I wrote 4 of 0 on purpose, right? Just like they did, okay? Because we're trying to go backwards in time. So this area the area of the circle is area of the half circle, semicircle, is 2 pi, because the area of the full thing is 4 pi. So if we take half of that, that's 2 pi. And it might be tempting to go, oh, well, this is below the x-axis. Isn't that negative, right? So we should be subtracting 2 pi, but we're going backwards. So we're doing the opposite, right? Because these bounds are from 4 to 0. And if you recall, when your bounds are backwards, you can write that as 3 minus 0 to 4. Well, the integral from 0 to 4 is indeed negative 2 pi. But when you take the opposite of it, it results in addition. Now, I hope I didn't get like blab on too much. You know how I like to do that. But I'm just trying to be thorough. But hopefully that makes sense. And if not, leave a comment on this YouTube video. Okay? Is there a way I can like easily clear my markings? All right, so let's move down to the next question, okay? Part B. So, find the x-coordinates of all points of inflections of the graph of f for 0 from 0 to 7. So, this is my justifications page, and hopefully you somewhat recall what a point of inflection is. But a point of inflection is when the second derivative changes sign, or in other words, the first derivative changes from increasing to decreasing. You can think of it either way, but what we're talking about here is it's asking what are the points of inflection of f? This is not f. This is f prime. So a point of inflection occurs when f prime changes from increasing to decreasing. So where on this graph is the derivative changing from increasing to decreasing? At x equals 2 is the first one, because when we say increasing to decreasing, we're not saying when does the derivative change from positive to negative. That's not what we're saying. We're saying when does it go from increasing to decreasing. This derivative is going down, down, down. It's decreasing, and then it begins to go back up, up, up. Now it's increasing. So right here at x equals 2 is when f prime changed from decreasing to increasing. And similarly, over at 6, the same thing occurs. This derivative is increasing, and then all of a sudden it starts to go down, and now it's decreasing. Increasing, decreasing. So at x equals 6, it changed from increasing to decreasing. So on my justifications page, you can say one or the other, and it's going to be true. So f of x has a point of inflection at x equals a because f prime changes from increasing to decreasing at x equals a. And you can see their explanation here. The graph of f has a point of inflection at x equals 2 and x equals 6 because f prime of x changes from decreasing to increasing at x equals 2 and from increasing to decreasing at x equals 6. Decrease to increase, increase to decrease. And thus, f will have a point of inflection. Let's continue on. Part C. Let g be the function defined by g of x equals f of x minus 6. On what intervals, if any, is g decreasing for 0 to 7? Show the analysis that leads to your answer. So if I go back to the justifications, I mean, you know when something's decreasing, when it's going down. Why would something be going down? When its slope is negative. And what represents slope? Derivative. So it asks when, if ever, is it decreasing? So what is it really asking then? It's asking when, if ever, is the derivative less than 0? When is the derivative of x less than 0? That's what this question is asking, right? It doesn't say that, but that's what it's saying, right? It's if you read between the lines, that's what it's asking. On what intervals, if any, is g decreasing? Well, when is g decreasing? When the derivative is less than 0. So what is the derivative of g? Well, you just derive f. Well, the derivative of f is f prime, and the derivative of x is 1. So hopefully that derivative makes complete sense. Well, interesting. F prime is the graph that they've given us. They gave us f prime. That's what this graph is. Yeah? So we want to know when is f prime minus 1 less than 0? In other words, when is f prime less than 1? Here's the graph of f prime right in front of you. So when is the graph less than 1? It is less than 1 from 0 all the way up until 5. From 0 all the way until 5. That is when the graph is less than 1. I think I said 0 just a moment ago. I meant to say 1, right? And that is why this response is what it is, right? From 0 to 5. So we have to have a analysis. We have to have a sentence, right? The graph of g is decreasing from 0 to 5 because the derivative is less than 0 on that interval, right? That's important. That's what we're stating. All right. For the function g defined in part C, find the absolute minimum value on the interval 0 to 7. So we're talking about g, not the graph. The graph is going to help us, but we're not talking about the graph. We're talking about g, and g is still the g from the problem before. So how do you find an absolute minimum? An absolute min or max can be found by using the candidates test. The candidates test is when you make a table of values, and you test the endpoints, endpoint 1, endpoint 2, and any critical points in between, okay? Any critical points in between those endpoints. We want to test all the critical points. What's a critical point? When the derivative is 0. A critical point is when the derivative is 0. Okay? So that's what we're going to do. Now, the solution here says something different, but if you look at the scoring notes, it also accepts the candidates test. And that's what we've discussed in class, and that's what I'm going to do, so I don't have to sit here and read through this. All right? So here's the solution using the candidates test. They said, all right, g prime of x, we want to know when it's equal to 0. It's equal to 0 at 5 and 7. How do we know that? Because of the graph. When this is f prime, right? And g prime is f prime minus 1. So f prime is equal to 1 here at 5 and here at 7, right? It's equal to 1 at 5 and 7. And therefore, it's equal to, I think I said 5. It's equal to 1 at 5 and 7. And therefore, g prime would be 0 because 1 minus 1 is 0. So that's where 5 and 7 are coming from. G prime is f prime minus 1. When is this thing equal to 0? Whenever f prime is 1. And f prime is 1 at 5 and 7. So we take those 2 points and we're going to test them. We're going to test the point 5 and we're going to test the point 7. Now, where did these numbers come from? Also, why are we testing 0? Because it's the beginning of the interval, right? We test the endpoints. 0 and 7 happens to also be a critical point, interestingly enough. But we test the endpoints 0 and 7, and then we test that other critical point of 5. So we're testing all three. So g of x, if you recall, is f of x minus x. Well, we already know what f of 0 is. F of oops. F of 0 is 3 plus 2 pi from part A. From part A. And if x is 0, that means we're subtracting 0, which doesn't do anything. So that means g of 0 happens to be the same as f of 0 because we're subtracting nothing. Now, remember, g of x is f of x minus x. So how do we find g of 5? How do we find g of 5? We do f of 5 minus 5. And f of 5 is 3.5. We found that in part A. F of 5 is 7 halves, or 3.5. So 3.5 minus 5 is negative 1.5, which is negative 3 halves. And now how do we find f of 7? We're going to do, g of 7. We're going to do f of 7 minus 7. Now, we haven't solved for f of 7 in a previous problem. So we're going to have to do the same thing that we did in part A in order to find f of 7. So f of 7 can be found by simply saying, all right, we know that f of, oh, that was a crazy line. We know that f of 4, we know that at x equals 4, it's equal to 3, right? And we simply need to add the integral from 4 to 7. Well, the integral from 4 to 7 is, well, we're going to have to do some geometry here. Let me erase the integral from 4 to 7. So here's a triangle, and the area of that triangle, that's 2 by 2. 2 times 2 is 4, but you have to take half, so that is 2. And then this triangle is a half, and then this square is 1. So that's going to be 3.5. You feel me? So the integral from 4 to 7 of f prime is 3.5. So 3 plus 3.5 is 6.5. So f of 7, like if this was another part of the question, f of 7, when we add that integral, is 6.5. So we're doing 6.5 minus 7, which is negative a half, which is where that came from. So what is the minimum? What is the smallest number that we have here? Well, 3 plus 2 pi is positive, so that's not a minimum. The negative 3 halves and the negative half are both negative, but negative 3 halves is smaller. So negative 1.5 is the minimum. So if we further analyze this problem, right, they're giving us 2 points here. What do we want to do? We set the derivative equal to 0, and they're going to give us a point, and then our justification is the candidate's test, and then we just simply want to state the minimum, right? A nice simple sentence that the absolute minimum value of g on the interval 0 to 7 is negative 3 halves. We're just taking their words and throwing them back out at them. I said this in the other video. Just get rid of the word find and turn it into a complete sentence. The absolute minimum value on the interval 0 to 7 is negative 3 halves. You don't have to invent a sentence. Just take their words and take their question and turn it into an answer. A further comment here that they said, since I'll just read this on the fly, when using a candidate's test, the response may import an incorrect value. Oh, okay, never mind. So I hope that made sense. This video was certainly shorter. I think at the start I was maybe a little clunky here, but it's just a little strange to look at a graph and like come up with values, right? Here, if you're willing to stick around, I'm going to pause myself real quick and I'm going to draw something. Okay, so I'm back, and if you're watching the video, great. I have no idea where I left off. This took a lot longer to make than I thought. I was fiddling with Desmos. Anyway, here is the derivative f prime that is on your paper, right? You can see how that's the same. Well, I integrated all of them and plotted them and created f. You're looking at f. So the integral of a semicircle results in this curve like this. Does this curve make sense? Well, the semicircle is entirely in the negative, correct? It's entirely in the negative. What does that mean about our function f? If the derivative is negative, that means our function is decreasing. So f is decreasing the whole time. The semicircle is in the negative, so therefore our f is decreasing. Now, what does the semicircle mean here? Well, it gets more negative and then less negative. So what does that mean about our function? It decreases quicker and then starts to decrease slower. So it's decreasing quicker and then decreases slower. Yeah, it's starting to like maybe slow down and like bottom out. This has like a peak almost, and then it speeds up and then slows down. You can see I've labeled the points. By the way, 9.283 is 3 plus 2 pi, right? Our f of 0 was 3 plus 2 pi. So there's that point, and then there's the given point, 4, 3. And so this line, remember, lines integrate to become parabolas. So hopefully this looks like the start of a parabola, because it is, right? So this line integrated to a parabola, and this is entirely positive, and that's why our function has started increasing. That's why it's going back up. All right, and there's that 5 comma 3.5. We found that on in part A. And then when this line changes to this line, the function is still increasing, right? Just because the derivative is going down doesn't mean our function isn't increasing anymore. It's still a positive derivative. This blue part of the derivative is still positive. It's getting less positive, but still positive nonetheless. So that's why our function continues to increase. But because it's getting less positive, it's starting to increase slower, right? It's starting to increase slower. And eventually, if this kept going, all of a sudden it would flatten out and then start to decrease. Okay? So hopefully these pieces all glued together make this derivative make sense. And why is the function here? Like what's stopping this function from being down low or up high? All because of the given value of 4, 3, right? F of 4 equals 3. So everything else is where it is because of that given point. So hopefully I've kind of made some sense of things there. And I hope you enjoy the rest of your whatever day you're watching this. Peace out.